morning, everyone. It is another lovely
Good morning.
Sunday. Good morning, Dr. Ghulam. Thank you for
Good
joining us
morning.
again. Yes. So today, Pasarkita is honored to bring Dr. Ghulam with us again, the expert in soil quality. So for those who are new to Pasarkita, we are a platform that helps connect urban growers to market their product and sell it to the consumer. And together with us is Dr. Ghulam. He has been joining us for a few sessions. You can go to our YouTube page to look for Dr. Ghulam's previous recordings. So Dr. Ghulam is an expert in soil quality. In previous show, Dr. Ghulam talks about uh, how to improve the quality of our soil. Today, Dr. Ghulam will tell us about the losses and gains of plant nutrients in cropping system. So the topic for today is about what are the factors that affect the losses or the gains of nutrients in our cropping system. So I will pass this to Dr. Ghulam to start today's topic. Dr. Ghulam is to you.
Thank you. Assalamualaikum. Good morning, everyone. Today, I would like to say a few things about plant nutrients in the context of growing crops or growing anything, flowers or crops. And I will try to say a few things about how plant nutrients are lost and sometimes gained in any cropping system, whether it's in a farm or in our backyard. And at the same time, how do I go to the next slide?
Uh, yes, you go to your PowerPoint and click next. Just click.
Next. I will be talking about losses and gains because everything in this world is sometimes like a cycle. Sometimes you lose, sometimes you gain. But actually, for nutrients, it is not exactly a cycle. It is like a cycle, but there are leaks here and there. So I'll try to explain to you how we can reduce the losses. That means stop the leaks if there are any, and also keep making the nutrients do its job to feed the soil and then the plants. There are various processes, natural processes that occur with nutrients when we apply them to the soil and to the crop. And sometimes the nutrients will change its form and characteristics. And I will try to highlight what are the major processes and how some of the pathways are affected. First of all, maybe we should have a look at the water cycle, because almost everybody knows about the water cycle, and we know that the main processes involved are rainfall, or sometimes known as precipitation, rain and snow, and then there's evaporation, transpiration, condensation, and so forth, because the water cycle is quite a complete cycle, because sometimes it exists as a liquid, and then when the temperature changes, it evaporates and becomes a gas, that is water vapor, and rise up to the atmosphere. And also the plants will also transpire. That means we'll release water vapor into the air. And then when they reach the atmosphere and conditions are favorable, then they condense, and then sometimes they'll come to a point where they fall as rain or snow. That is called precipitation. And when the rain falls, then the water collects in streams and rivers. Sometimes there's runoff from the land, and sometimes when the soil is suitable, it, it goes into the soil and becomes groundwater. But finally, it will collect in the main river and right into the sea. And then the cycle goes on again with evaporation, transpiration, and so forth. But we can also look at nutrient in the form of a cycle, more or less a cycle. And I took this diagram from a paper by Muhammad Mahabubur Rahman and his colleagues. They wrote a paper on the role of quantitative traits of leaf litter on decomposition and nutrient cycling. And in their study, they focus on some of the things that happen below the soil surface, that is in the ground, which normally we can't see. And they discuss in some detail about nutrient uptake and how the roots take up the nutrients and channel it to the plants or the trees. And then there is also how the nutrients exist in soil solution in the soil, in the below the ground. And then he also mentioned about the process of decomposition and mineralization. That means the organic matter that is produced by trees and animals that go into the soil are acted upon by microorganisms. And these microorganisms um, help to the organic matter to decompose and release the nutrients. At the same time, there is also an input from the rocks below the soil. That means the parent material of the soil. The rocks are actually slowly weathering. That means they are also changing and release some of the nutrients, but maybe in a very, very slow way. But the soil is actually also receiving minerals, which can then become the nutrients from the rocks that are slowly decomposing. And then also nutrients can be lost from the soil in various ways. It can become gas and lost from the soil. And also it can be subjected to various other forces like leaching and so forth, where it can be lost from the soil. But one thing to remember, the microorganisms in the soil is also capable of taking nutrients from the air in a process called fixation. And this is aided by several specialized microorganisms. Again, if you look at it in a slightly different way, from a diagram which I have taken from another publication, the Free University of Berlin. And here it emphasizes again that the rocks below the soil, that means the parent material probably, are also slowly weathering and releasing nutrients. And also from the air, the microorganisms fix the nitrogen from the air, and also the dust from the air also uh, deposits some nutrients on the ground. And of course, the main sources are from the plants, trees, and animals that provide organic matter to the soil. And then the microorganisms, in this case, is called decomposers, break down the organic matter to release the nutrients. And then the roots will do their part in taking up the nutrients for the plant or the tree. Before we go any further, we want to talk about the sources of nutrients. Try to make two lists. Of course, these lists are not comprehensive. These are the main items that I can think of for this talk. And of course, when you grow something to get the fruit or the vegetables or the nuts or whatever, the first thing that you normally put in is the fertilizer. The fertilizer can be of a chemical nature or organic, depending on what form of agriculture you are practicing. Of course, sometimes in addition to fertilizer, there is manure, there is waste from animals. Sometimes some systems use manure, some do not. Some depend mainly on fertilizer. And another important input usually for people who appreciate the good qualities of compost is to add compost to the soil, because compost gives not only nutrients, but organic matter, well-rotted organic matter, and microorganisms. And then in a good system where you don't throw away anything, because you make use of the plant residues. That means whatever that you don't harvest, you don't throw away. You return them to the soil. And again, the atmosphere provides nutrients which some can be fixed by the microorganisms. And then the dust in the atmosphere also sometimes contributes some uh, nutrients to the soil. And on the other side, when you, as I said before, when you engage in crop production, whether it's in a big scale or a small scale, normally your intention is to harvest the fruits or the leaves or the nuts or whatever. And in this way, you are actually taking out the nutrients from the system, because the nutrients that were initially taken up by the roots to the tree or the plant is actually quite a substantial amount of it goes into making the fruits and the leaves and the nuts or whatever that you intend to harvest. So that is a major loss. Another major loss to my mind is soil erosion. If the system does not practice good erosion control, then soil may be lost. And when soil is lost from the system, it carries with it the nutrients. The nutrients are usually attached to the soil. And also, if you allow runoff to take place during heavy rainfall, then there will be some nutrients dissolved in the runoff water, and this will be lost to the streams or rivers. Another soil process that also is responsible for the loss of nutrients from the soil is a process called leaching. This happens when there is a lot of water, either from rain or from irrigation, that is poured into the soil, and there is excess water, and this water is able to dissolve some of the nutrients. That means some of the soluble nutrients are dissolved in the water, and the water, if it's in excess, will flow down through the soil profile vertically and away from the root zone of the plant or tree. Of course, there are reactions in the soil that can produce gas, and this includes when you burn things on the soil surface and other processes related to it. Then let us take a single plant or a single tree just to enhance our understanding. As we all know, as I've said before, the nutrients in the soil, when added to the soil or formed within the soil, are taken up by the roots for the plant or tree. The roots play a very, very important function. That means to take up water, nutrients, and what other things that the plant or tree needs to grow and develop, and to form fruits, to form leaves, to form branches, and to form twigs. But as the fruits and the trees mature, they turn brown. For the leaves, they turn brown, and then they drop to the ground. Similar, the fruits, if you don't harvest, they will fall to the ground, and then they will undergo decomposition. And this again returns the nutrients back to the soil. That means in this case, it is also a small cycle. And remember that the leaves and the fruits and the flowers will fall on the soil surface, and then they will undergo decomposition. This is the job of the soil fauna and the microorganisms. They act on this, and this layer of leaf and so on is normally referred to as the litter layer. And again, as I mentioned earlier several times, when you grow something, either in your farm, in your backyard, or in your plantation, actually you want to harvest something. You want to eat the fruit, or you want to uh, extract oil from it, or you want to extract latex or whatever. So when you harvest a fruit, for example, you eat the fleshy part, but some of the other parts are not consumed directly by you. So actually, you should consider all these different parts other than the flesh or the whatever you consume as also a natural resource, because they came from the soil, from the nutrients in the soil and from the water and so on to form these things. And if you put them together, they become a substantial amount of natural resources that you can put to good use. And this is some of the things that you can use to make compost, because compost helps to break down, to decompose all these materials into a form which afterwards you can't recognize them anymore. For example, this peel, this orange grapefruit skin and so on. Now you can tell it's grapefruit, it's dragon fruit, but once you turn them into compost using the right techniques, give it the time it requires, then you won't recognize anymore. So you may get something like this, a very good, well-formed compost, full of organic matter, nutrients, and even microorganisms. And when you apply it to the soil will be very happy. It will make the soil very fertile and with very good soil structure. And then that is a major gain for the soil. You gain nutrients, you gain organic matter, and you gain microorganisms and so forth. But all that you give to the soil sometimes can be lost if you are not careful on how you manage your farm. And to me, one of the major processes of soil loss and nutrient loss is soil erosion. If you have a nice farm like this, but you apply fertilizer regularly and you look after it, but you don't care to provide the protection against soil erosion. And when the big rains come, you normally will have to experience soil erosion. And what happens when soil erosion occurs? Normally, it's the top layer of soil that is transported from the soil and away from from your farm. And this is the layer of soil that contains most of the nutrients. If you remember in the diagram earlier, the recycling of the leaves and the fruits and so forth, all of them fall on the surface. And just below the surface are the microorganisms that act on these materials to decompose them and to release the nutrients. And most of the nutrients are in that zone, the top layer. And when soil erosion occurs, that is the first layer that will be uh, re, uh, washed away, and then you will lose a lot of your nutrients in this way. This is another example of soil erosion in a big field where there is no erosion control practice that can help to reduce the, the movement of soil. And also recently the soil has been disturbed physically, maybe to remove weeds and so forth. But then in these early stages, when the soil is so exposed and so vulnerable to soil erosion, there should have been some erosion control measures. Otherwise, you will get this. The topsoil is lost, carried away, and redistributed within the farm. So this will make it easier for the system, the farm, the plantation or whatever, to lose the nutrients. Uh, while we are talking about soil erosion, maybe we can take one step back and go back to some of the basic information about soils. Most of you who have studied soils will know this very well because soils normally, the normal soils, are composed of clay, silt, sand, and of course organic matter. The clay, silt, and sand are the mineral components. The organic matter is the organic component. And among these three, clay, silt, and sand, they differ greatly in the size of the particle. Clay is very, very, very fine. And also, it is different in mineralogy. That means it has a very large surface area because it's very fine. And its surface is also charged, negatively charged. And when it's charged, it is very prone it is attracted to positive charges. And so that's why soil aggregation usually starts with the clay particles. But apart from that, when the soil is eroded, as the soil erosion occurs, in the uh, in any project that measures soil erosion, it is now possible to separate the eroded soil into two fractions. What is called a suspended load, which is suspended in the water, and the bed load which moves in the bottom part of the flow of water. Because of the differences in size, the smaller size ones, the suspended load, uh, normally floats or suspended in the flowing water, whereas the bed load does not because it's heavy and it's coarse. So when you sample these two fractions of eroded soil, or sometimes called sediment, then you can see that there is a very great difference in the amount of nutrients in these two fractions. The suspended load, of course, being very fine, is composed largely of clay, and this is where most of the nutrients are attached. And I'll show you something here in the next slide, I think, where some measurements have been made. The original soil that is on in the ground, that means before it was eroded, is sampled. Also, when erosion occurs, the bed load or core sediment is also sampled, and then the suspended load or fine sediment is also sampled. And then these were analyzed in the laboratory. In this case, it's for nitrogen, just as an example to show you the differences. As shown here, you can see that in this column, where the nitrogen content in coarse sediment, the nitrogen content is quite low, 0.04 and 0.08. Whereas in the fine sediment or the suspended load, when we analyze it for nitrogen, it is much higher compared to this, 0.27, 0.23, and so forth, even 0.32. So when you compare this with the original nitrogen content in the soil before it was eroded, you can see that the eroded soil that in the fine sediment, the fine suspended load, contains much higher nitrogen than the original soil in all these examples that I give here. And the bed load or the coarse sediment is more or less the same as in the original soil. So that shows that it ties in with what I said before, that when erosion occurs, it's the surface layer that is being eroded first. And this is why the amount of nutrients lost in erosion is much higher than the original content of the nutrient. So this is just an example of nitrogen. You can do this for other nutrients as well, potassium, phosphorus, calcium, and so forth. And in the farm that I showed you, the papaya farm, where you see the erosion occurring, at the bottom of the farm, you have these reeds or grasses. And this is very thick, and all the eroded soil from that farm accumulate here because it's stopped by growth of grass. And this is where the eroded soil or the sediment is deposited. And if you take a sample of this and analyze it in the laboratory, you will find that the nutrient contents is very high compared to the original soil. Also, it can happen in other fields where erosion control is not practiced adequately. And you will find deposits like this at the bottom of the farm or the field. And this is also is a deposit of sediment or eroded soil. And again, this material, if you analyze it, will have a high contents of nutrients. Apart from soil erosion, which is a major soil process where both soil and nutrients are lost from the field, other practices include burning. Burning will cause a rise in temperature of the soil, which will then drive away the microorganisms, and also reactions that will release gas into the atmosphere. The gas can be from nitrogen or can be from other nutrients. And so that is another way that nutrients are lost. This is a pathway of loss. So burning is another way of getting rid of the uh, plant discards, or the plant that you don't harvest, the part of the plant that you don't harvest, the unwanted parts. Uh, Earlier, I also mentioned that the natural way for trees and plants is when the leaves mature, they fall to the ground. This is nature's way of recycling the nutrients. But sometimes, although you leave it on the soil to allow it to decompose, sometimes they are washed away by heavy rain. And sometimes owners purposely remove them because they are regarded as trash or rubbish. But this is another way of losing the nutrients from the system, because all these materials should remain on the soil for the microorganisms to act on them to release the nutrients to the soil. Another process that is not very easy to see because it happens underground is leaching. This happens when there's excess water and the soil is of good structure, so the water uh, infiltrates the soil profile. And when it does so, there are some nutrients which are very soluble in water, and that excess water will continue percolating down the soil profile and carries with it the dissolved nutrients. So in this way, you also lose nutrients away from your uh, agricultural system or from your backyard. Other than adding fertilizer, compost, manure, one of the things that you can do to retain nutrients in your farm or your enterprise is to return all the unwanted parts that you have. After you harvest, you don't throw away the stalks, the leaves, and others that some people consider as rubbish or trash. These are very useful way of returning nutrients to the soil. So this is a good example of a farm which optimizes the resources, the nutrients and its resources, so that it is not lost from the system. Again, this is the same story that I spoke about earlier, the leaf litter that should be retained here because it's the food of microorganisms, and the microorganisms are the ones responsible for turning this into nutrients and returning it back to the soil. It came from the soil and it is finally returned to the soil. Another important aspect of this nutrient addition to the soil is the practice of planting leguminous plant species. For example, in our rubber and palm oil industry, they they practice this quite widely. They plant leguminous cover crops. These crops have the special ability to fix nitrogen from the atmosphere. They are associated with microorganisms that has the ability to fix nitrogen from the atmosphere. And not only that, some of these species are very profuse in producing the leaves or the foliage. And these leaves contain also high amounts of nutrients, nitrogen, phosphorus, calcium, potassium, you name it. They have plenty of it. And then they also are known to be to grow roots in the soils, in the topsoil, and these roots decay very rapidly. And then when they decay, the new roots will regrow, and this is a very good way of adding organic matter to the soil, and also from the organic matter, the micronutrients will act on them and release nutrients. So this is a very good recycling of nutrients. This is part of a very efficient recycling system. And important, these cover crops, usually if managed properly, are an important source of plant nutrients for the agricultural system. Let's move quickly. And again, I want to emphasize the fact that the soil needs to be regularly supplied with all the good forms of organic matter and nutrients. And that is the way to make the enterprise successful, in a sense that you manage the nutrients properly, avoid losses, understand the processes that are affecting the gains and losses of nutrients. And sometimes, in order to make use of this knowledge of what nutrients are present, how to add nutrients, what nutrients to emphasize on, and so forth, and what are the sources of these nutrients. Some people who are in this business create nutrient balances. They can construct a nutrient balance based on the data that is available. They can get data by measuring, or they can get data from statistics on the farm practices, on the inputs of fertilizer, and so forth and so on. And also, they can predict processes like soil erosion, leaching, and so forth by using models. And in this way, they can get a very complete picture of the gains and losses of nutrients in any system, whether it's a farm or a district or even a region. What they do here when they construct a nutrient balance is to get as much information as possible that is from good sources. That means reliable information, reliable data, and then they construct this side inputs, the other side outputs, and compare. From there, they can see for this particular district, for example, what is the most important action to take to restore the balance. For example, if the balance shows that the district is losing a lot of nutrients through soil erosion, then they must come up with a strategy to reduce the rate of soil erosion for that particular district. So here I would like to show you something, a table which I took from a publication by Smalling. And if I can refer, Smalling wrote a paper on soil nutrient depletion in sub-Saharan Africa. And it was published in a book by von Reuter and Pring in 1993, published by UKP of the Netherlands. It is very interesting because I'm sure the author had access to a lot of information about the agricultural activities and situation in the Kisii district in Kenya. And he managed to draw up this table showing the inputs of potassium in this case. K is potassium, and then the outputs of potassium for that particular district on a district scale with all the information that he has access to. And he broke up into mineral fertilizer, manure, and atmosphere. And if he found that in that particular district, the main input is from manure. That means animal waste. And there's some from fertilizer, not very much, and some from the atmosphere. So the inputs, he total up to be 31 kilograms of potassium per hectare per year. And the outputs, the crops were harvested. And so he calculated that from the crops in 1 year and on 1 hectare, 43 kilograms of potassium were lost by harvesting the crop. That is the purpose of the agriculture anyway, to harvest the crops. So the 43 there, and then the crop residues, only 13. And leaching, probably through prediction or measurement, I don't know, 9 kilograms potassium. And soil erosion, very high, 36 kilogram of potassium per hectare per year. And the total is 101. As you can see, the outputs or the losses is 101 kilograms, whereas the inputs or the gains is only 31. So there is a balance of minus 70. So from here, assuming that all the values are accurate and reliable, you can see that this one you cannot do anything because you harvest the crop. That's your purpose of growing them anyway. The soil erosion is very high, a contributor to the loss of potassium. So to me, one needs to do something about erosion control here in this Kisii district. And also the crop residues, as far as possible, should be returned, not removed. The current practice at that time was to remove the crop residues, but they should find ways of returning the crop residues because the crop residues contain potassium, since you are working on the potassium balance. Yeah, so that's why I said here, decisions improve erosion control throughout the district and return the crop residues to the soil as far as possible if it doesn't interfere with the enterprise. And this is another example, but this one is on an experimental plot level. And this is taken from a paper by Ed Paningbatan, who I worked together with for some time in the 1990s. And here he is looking at two systems. One system of growing mung bean and maize with some hedgerows. Hedgerows are planted in order to reduce soil erosion. Whereas the other system, mung bean and maize, but without hedgerows. T1 is without hedgerows. And because T1 doesn't have hedgerows. So there is no contribution from the hedgerow. Whereas crop residues have contribute to the nutrients. Here is nitrogen. And for T3, because hedgerows were continuously cut and returned to the soil, then the nitrogen from the hedgerows contribute to the gains. Whereas crop removal can't be helped because that's what they grow the mung bean and maize for, is to harvest. And because there is no hedgerow for T1, the soil erosion is very high. The sediment contains 296 kilogram of nitrogen per hectare per year, whereas where the hedgerows were present, it was not as high. So the balance is for T3 is positive 170, whereas for T1 is negative. So this tells them that hedgerows help a lot, not only in increasing the inputs or the gains of nitrogen, but also reducing the loss through sediment. So these are two examples where you can see that this nutrient balance can help to make decisions on the management of the agricultural enterprise. And I think I should end here, and I should say that uh, we need to be aware of all the natural processes that occur in the nutrient cycle, if you can call it a cycle. And then we know what is actually happening in the ground, what we can do to improve the situation. And of course, the major processes such as erosion, runoff, and leaching should be understood and tackled to reduce losses of nutrients from the system. And then you can draw up uh, nutrient balances to help you make important decisions at the farm level or at even the district level or even at the national level. Okay, thank you, Mike. I think that's all.
Thank you very much, Dr. Ghulam, for your informative discussion on this soil. So I learned a lot today, and you have helped me to change my perspective on the soil, how we look at soil as a system, as a living system, rather than uh, just a piece of soil. Okay. Uh, I was really amazed by how you break them down into the losses and gains, and at the same time you talk about how what are the methods that we lost nutrients in soil. uh, Now I understand that, oh, so the fruits that I'm having, the mango that I'm eating, is actually nutrient from the soil, and it should be it can be looked at as water that the plant gets from the soil. So this is really mind opening. And you mentioned about the burning. Okay, I thought that burning the plants, the crops, like are actually creating more nutrient for the soil. Because this was what I was made believe that when we burn the leftovers, right, the plants, and when they turn into ashes, it is very fertile and it's very high in nutrient. Isn't that true, Dr. Ghulam?
When you burn, of course, the ones that don't cause reaction to produce gas will remain on the soil in the form of ash. But then this ash is right on the surface of the soil. And the burning itself and the clearing exposes the surface to soil erosion. And when heavy rainfall comes, a big rainstorm, it will wash away the ash very easily. The ash is very light and exists on the soil surface. But also you must remember you lost through the burning some of the gaseous materials. And also the temperature of the soil becomes very high, all the microorganisms will run away. They cannot survive in such high temperature. So that's why burning is not a good practice to do. Of course, you have to get rid of some things, but there may be you have to find other ways of doing it. But as far as possible, keep the plant residues on the soil surface. Let them rot. I'm sure they are practicing this a lot in the plantations in Malaysia. And in fact, I think the Malaysia now bans open burning. So you don't see much burning except in isolated places.
Dr. Ghulam, one more question about plantation. When they, well, a lot of the plantations, commercialized plantations, right? They tend to spend a lot on the fertilizers, buying fertilizers. And there are people who believes that we need to get rid of the grass or the plants, those are unwanted plants, before they fertilize the plantation because they don't want the nutrient to be absorbed by the grass. What is your view on this?
It depends on the situation. Of course, if you have other vegetation, grass or whatever, then the grass will take up nutrients. But the grass also have their own function. If you manage them properly, uh, they will give you some advantages. Because I think earthworms and other soil fauna will like to live under the grass, and also microorganisms because the grass roots will decay and so on. But of course, you have to manage the grass. You can't allow the grass to grow wild. And in plantations, normally they will plant the cover crops, the leguminous cover crops. These are very good. They add a lot of nutrients to the soil. They make the soil structure better. They encourage microorganisms. So you have to look at the situation, and if there is grass, you have to manage it properly. You can even recycle the grass clippings to make compost.
I see. Yeah, I get your point on this because, as mentioned by you earlier, one of the main problem losing nutrient is due to soil erosion. So it's still worth protecting the soil rather than just letting the nutrient from the topsoil to just get washed away by water. I think that is the something that everybody don't want to happen on their plantation. All right, Dr. Guram. So we are already at the end of our session today. Thank you very much for your sharing, and it is very, very informative. It does